Hello world. So we have talked about CNNs in earlier videos. Now I want you to talk about something enormous, and that is RNNs. And so RNNs have been a topic of great deep learning research and are being used heavily everywhere. And so why do we need RNNs? So as you've seen, convolutional neural networks work so much better with structured data. But what about neural networks in which we want to have persistence in their thoughts? I mean, if you feed this piece of code over here, how are you going to expect a neural network to close the parentheses where we want? And so that's what memory comes into play. And with memory, we have long-term dependency as well, so it has to retain the information which we passed in earlier. So it's going to make use of the previous state as its input in the current state, and these models are called attentional models, and we make use of sequence modeling. So let me just give an example over here. So humans don't start thinking from scratch every second, do they? And as you are listening to me, you understand each word based on your understanding of previous words. You don't throw everything away and start thinking from scratch again. Your thoughts have persistence. And so traditional neural networks can't do this, and it seems like a major shortcoming. And then we come back to why do we need RNNs. So if we want to classify what kind of event is happening at every point, it's unclear how our traditional neural network could use its reasoning about previous events, and that's why we use RNNs. We can make use of the persistence, and they address this issue so very well. They are networks with loops in them, allowing information to persist. So as you can see a loop of neural networks over here. A loop allows information to be passed from one step of network to the next. So these loops make recurrent neural networks, and it may seem some kind mysterious. However, if you think a bit more, it turns out that they are not all that different than a neural network. It can be thought of as multiple copies of the same network, each passing a message to the successor. So as you can see over here, there are loops, and information is going to be passed on again and again, so that it's going to retain the memory which we want. Now let's come to the question, what can RNNs do? At this point of time, RNNs are being actively researched upon, and they have been used greatly in fields of natural language processing, language modeling, generating text, and RNNs have shown great success in NLP tasks. I should mention that some of the commonly used type of RNNs are LSTMs. So LSTMs, we'll talk about those in later videos. So given a sequence of words, we want to predict the probability of each word given the previous words. In predictive typing also, RNNs are being actively used. So Anish Tripathi wrote an article on his blog, and I'll give you a link to that also. So you can see the neural network is learning to recognize the images, and it's tracing the entire figure. So the takeaway is that even if your data is not in the form of sequences, you can still formulate and train powerful models that learn to process it sequentially. You are learning stateful programs that process your fixed size data. This was a fun exercise, and what he did is he fed the entire Shakespeare literature to the neural network, and this is what neural network came up with. And it's fun to see a neural network write Shakespeare. So let's talk about one example over here, machine translation. So it's similar to language modeling in that our input is a sequence of words in a source language. We want to output a sequence of words in a target language, that's English. A key difference is that our output only starts after we have seen the complete input, because the words of our translated sentences may require information captured from the complete input sequence. The chain-like structure over here reveals that recurrent neural networks are intimately related to sequences and lists. They are the natural architecture of neural network to use for such data, and they certainly are used. In the last few years, they have been incredibly successful applying RNNs to a variety of problems such as speech recognition, language modeling, translation, image captioning, and the list goes on. And they still have a long way to go, and we don't know what fields are they going to see their use in. And so essential to these successes is the use of LSTMs. They are a very special kind of recurrent neural networks which works for many tasks much better than the standard versions. I hope you gather some intuition on what RNNs are and why do we need to use it and why they are so much incredible and powerful neural networks. And feel free to share this video with anyone whom you see are learning deep learning, and don't forget to subscribe. That's what keeps me going. Thank you so much. I'll talk to you in the next one. Please.